All right, in that last analysis of grid graphs, we ended up discovering that the number of edges is 2 times the number of nodes minus 2 times the square root of n number of nodes, which is such a terrible function. But the fact of the matter is, as these analyses get more and more complicated, getting detailed answers like this is more and more cumbersome. Researchers have worked out a scheme for talking about functions in a much more high-level way while still being completely rigorous, but without getting bogged down in all the details. And this is the notion of asymptotic growth. You may have heard it described in the form of Big O notation. And we're going to get to Big O in a moment, but we need to start off with Big Theta. So Big Theta of a function g of n is actually a set of functions, specifically the set of functions that grow equally quickly as g of n. So to be a bit more formal about it, we say that some function f of n is in the set of functions equally fast growing as g of n if and only if there's some constants c1 and c2 and some threshold n0 such that for any n bigger than n0 we have something that looks like this. The function f of n for all these values of n, all these big values of n, is sandwiched between c1 times g of n and c2 times g of n. So to illustrate this idea with a picture, imagine we have some function f of n. It grows as n gets bigger, f of n gets bigger. But we also have some function g of n that we can multiply by c1, or we can multiply by some bigger number c2. And what we find is that once we get out to the right of some threshold n0, f of n is always between c2 of g of n and c1 of g of n. So in the beginning, maybe weird things happen, but once we get out far enough, asymptotically, in the limit, as things get really big, f of n lies between c1 times g of n and c2 times g of n. If that's the case, if such c1, c2, and n0 exist, then we can say that f of n is in big theta of g of n.